Hello, everyone, and welcome to the latest edition of our podcast interview series. As always, we want to make these sessions interesting and interactive, so please do introduce yourself on the chat channel, wherever you're joining from, however you're joining, and tell us where you're from and what you do. And of course, please do feel free to add your questions to this conversation. Now, today's interview, as you well know, is with the incredibly talented Amber Roberts, data scientist at Arize AI, and our topic of the day is troubleshooting large language models. But before we get into that, I want to share a few quick slides, which you can see on your screen. We have a lot of upcoming events at ODSC here and other ones. One I'm super excited about is we're continuing our Boston in-person meetup series. More specifically, that's in Davis Square. So if you're in the New England area, Massachusetts, please drop by on Tuesday. That's being hosted at Basis Tech. And I believe the topic there is actually, again, on large language models. And as you can see, another big announcement we have is we had a very successful data engineering summit last year around this time virtually. But this year we're co-locating that at ODSC East on the April 23rd and 24th. And by the call for speakers is open. I think it's open for a few more weeks. I know it just opened last week, but it's open for a few more weeks because we don't have a whole lot of slots left. So if you want to talk about data engineering, please join that. And of course, the main event, at least for our spring, is ODSC East in April. Team is doing a fantastic job of putting together a unbelievable roster of speakers and topics. The speaker committee just finished reviewing, I think, at least 50% of that content from submissions and invited speakers, and really, really excited about the lineup we have. And I believe there is a prelim schedule being announced next week, Monday or Tuesday. So keep an eye out for that. And of course, there are training passes available, free passes, expo passes, and that will be hybrid, meaning in person and virtual. So no reason not to check it out. Again, a great place to check out some speakers. And of course, previous interviews and webinars and everything else we do is available. Some very popular talks we've ran recently. So let's get on to the main event. I'm very excited to have this show today for two main reasons. One is today's conversation is about a very vexing problem even myself and my small data science team face, and that is troubleshooting large language models. So we're going to take a deep dive into troubleshooting large language models. A very important part of that is choosing the correct metrics. How do we fix errors in our own larger language models or other ones we're using, dealing with different types of hallucinations, of course. And we definitely want to dive into new interpretability tools, because I'm sure you're used to using different interpretability tools for machine learning and data science, but there's some awesome new open source tools out there like Phoenix. So we're going to be touching that as well. So I'd like to introduce today's guest, who has spoken at ODSC a number of times. And I'm not sure, Amber, if you noticed, but you always get some of the best ratings. Anytime you speak at ODSC, it's always one of the most popular talks, not to mention some of the best rated talks. So our guest today is Amber Roberts, who's a data scientist at Arize AI. Amber, welcome to the show.
Perfect. Okay. I was still in backstage, so I wanted to make sure I was able to pop in here. Thanks so much, Seamus. And yeah, I always love going to the ODSC events, and I will be at ODSC East this year again as well. And yes, we're going to be talking about Arize, we're going to be talking about Phoenix and some of the more newer open source LLM tools.
Yeah, so Amber, let's start with giving people some of your background. Can you introduce yourself and tell us about your journey into data science and AI? Very interested to hear that.
Of course. So my name's Amber. Thanks everyone for joining. I also just like I like my talk sessions to be interactive, I want this interview to be interactive. So if you have any questions or any follow-ups, just put them in the chat and we'll get to those. So my journey into the AI space, I was actually an astronomer. So I have my master's in astrophysics. I was deciding if I wanted to kind of continue down that academic track. And around that time when I was finishing grad school, a lot of my friends went into this new role called data scientist. And it was great for astronomers that were working with literally astronomical amounts of data and understanding how that data works. Around that same time, machine learning started picking up in industry and in research. So I transitioned into tech from academia. If anyone has questions on how to do that, I give advice a lot to my friends, especially the ones that are just starting to dive into the tech world. I've been in tech now for a little over 5 years and primarily in the ML and AI space. I've worked as a machine learning engineer. I've actually done a stint as a product manager in the AI space at Splunk. And then now, most recently, I've been at Arize for a little over 2 years now, and we're working towards AI observability.
Yeah, it's fantastic. Very interesting to hear that journey, especially the astronomy background. I didn't realize that, and that kind of explains your virtual background a little bit. Yeah, I think we may be having some astronomy and AI talks at ODSC, because I was talking to a group at Harvard, and one of my favorite topics, by the way, and I see a lot of movement how AI is transforming a lot of aspects of astronomy and predicting celestial events and all that good stuff. So maybe we can dive in that later. But I do want to ask you about Arize AI, because ODSC and other folks like myself, we're heavy users of open source, as everyone knows. And we'll talk about Phoenix later, but just give us a little background on Arize AI, the mission there, and all that good stuff.
So Arize is an AI observability platform for monitoring and observing and troubleshooting your models in production. So some of the largest teams we work with have a variety of machine learning models in production, and they're starting to experiment and get AI models into production. We'll get more into Phoenix later. Phoenix is our open source solution, but we do have a free offering of the Arize platform. So if you want to get I saw a few people putting that they are in NLP research. If you want to get your NLP models, your CV models, your generative AI models, or traditional machine learning models into the platform, you can do so for free. Thanks, Irina, for the link at arize.com here. And you can sign up for a free platform. Now, doing so, you can set up monitors, you could set up dashboards, and it's ultimately to troubleshoot and resolve the problems you're having in production. And we've recently released a suite of LLM evals in addition to kind of more traditional evaluations. So there's a whole suite of tools that can be used, whether or not you have those models in production yet. But I would say primarily our users for the Arize platform do have models in production.
Yeah, and in a second, we'll share that link to Phoenix, the open source project as well. So let's get into the topic of the day, and we're going to talk about troubleshooting large language models. So what are the biggest challenges with large language models in production?
So I think we've been seeing a lot on hallucinations. That's kind of the big word that's been associated with these large language models, bad responses and bad retrievals. So with all of those being major issues, I think the largest one that we're seeing are based on search and retrieval. So getting bad retrievals from these large language models, that's kind of been the top one for our customers, essentially using search and retrieval systems or RAG, retrieval augmented generation techniques. Because a lot of times when you're using these third-party large language models, it can be really difficult to make sure that it doesn't give you bad retrievals with these, because you're providing all that additional information to that large language model. A lot of the times, if a response is really weird with these large language models, the LLM could be kind of hallucinating, kind of making things up. But a lot of times it's the information that you supply that large language model that it uses to make a prediction. So if it's just a crazy response, a lot of times it goes back to the bad retrieval of documents.
No, very much so. So I work with a small development team at Cortical Ventures where I do some work, and we've been working in LLMs for the last, I would say, since early summer. And yeah, we're still kind of struggling in certain parts to get good search and retrieval responses. And it's a fantastic use case as well, because platforms like Solar and Elasticsearch and great tools have been around a long time. And I do see a lot of enterprise search being replaced by this, as well as new applications, of course. So let's talk a little bit about why troubleshooting large language models is so difficult, the various aspects of that.
Yeah, so what makes these systems so difficult to troubleshoot a lot of times is the complexity of an LLM application framework. So for example, when I mention search and retrieval use cases, first you have that selection process of which large language model do you even want to use. So you're looking at LLM leaderboards, you're looking at research to try to figure out which LLM you should be using. Then you have an entire separate process that's indexing your own data. So you have your kind of internal team data that you want to use when a user asks a query. So then you have the whole process where if you have a customer that's interacting with your sales chatbot and it's asking questions, you need to build a retrieval engine. So the user asks a question, you can then search whatever documents you have that are most closely related to that query. That's an entire process. You have to do indexing, you have to do embedding, you have to find these similar documents, and then you have to feed both the question and potential answers to that large language model to then get a response for the user, and then the user has to rate that. So you can tell this is a more complicated process. There's a lot of great diagrams, especially in like the Arize documentation on how these systems work. But essentially, there's 9 parts to just asking a question and getting an answer when using a large language model. And you need to be tracking the performance of each part of that to make sure nothing's breaking in the process. Machine learning traditional models also have complications, but they're a bit more well known and they've been around longer. So it's the newness of these LLM applications. Seamus, I'm sure as you're seeing new companies are coming out every day in regards to LLM processes. So it's figuring out the best process and just making sure everything's running smoothly. So in terms of the issues with troubleshooting, it's that it could be such a variety of things. And then even once you know what those things are, it's hard to actually resolve those problems.
No, absolutely. Some of the stuff, some of our top of mind issues are definitely around, we're using some proprietary models and they're black boxes versus the open source one. And it's maddening how highly sensitive they are to various prompts and context and get that deterministic behavior we're looking for. Because we'll find like it'll be working for the end user one day for certain word, and then they'll change the wording slightly or the phrasing, and that will throw everything off and very hard to replicate and then diagnose those. Because like with a lot of companies now, we're building in our thumbs up, thumbs down box and explain the issue and trying to reproduce that. And then not to mention the unexpected behaviors you mentioned, but let's pull a thread that you just mentioned, which are the 9 parts of the LLM. So definitely want to go a little deeper into troubleshooting issues in large language models, whether they're open source or private models, like what kind of issues have you encountered? Because I just mentioned a few of mine. And how do you approach troubleshooting them? And it sounds like, I think the approach depends on which of those 9 parts you alluded to.
Yes, so there's obviously a lot of moving parts to these models, and Seamus, you mentioned kind of the open source versus proprietary model debate. Love to hear from the audience too of which models that they're leveraging. For the most part, these third-party large language models have beaten a lot of open source options in terms of performance, just because of the cost and massive amounts of training that these third-party LLMs do have. In terms of the kind of like the next parts for like, what do you do in order to troubleshoot these models? Really, you have to look at first, what do you want? Like, what's the use case you're going for? And then once you know which LLM you're using and you've already looked at the kind of leaderboard and metrics of that, you need to be setting performance metrics at each stage for your model. So for example, you mentioned like a thumbs up, thumbs down. So that's what we would call a response metric. So that's a user facing metric where the user can give feedback, like user satisfaction, like is it a thumbs up, thumbs down response? And if it's a thumbs down response, what's going wrong? And then with that, sometimes checking the latency, sometimes checking the prompt, like if you have a good retrieval, if the documents look like they have the answer you're looking for, then the problem's not going to be that retrieval document, it might be the prompt. And we do recommend that if things are mostly looking right, to experiment with prompt engineering to try to get the LLM to generate a better response, assuming you have the right documents. But again, it's kind of setting up monitors and flags at each stage to figure out what's wrong. Because it could be something like very subtle. And you mentioned, Seamus, like you change a few words and you get a completely different response, different answer. And sometimes because these are non-deterministic models, you don't change anything and you get a slightly different answer. So the process there is you just want to get as many good retrievals as possible, get them as relevant as possible, and then work with your prompt and LLM, experiment with that until you're getting like the highest user satisfaction.
No, I think that's great advice. We do have a few people commenting that they're using open source mainly. Thumbs up to that. So with these many issues, it's interesting to try and figure out what are the right metrics to use here, because as we dive into metrics for LLMs, it's not just using F1 scores. You have to look at the context, the engagement fluency. So how do you choose the right metrics for a specific LLM task? Because there's a lot of literature on this and a lot of insight going around on it, which is a big ask.
Yes. A well-researched question. I think more research is consistently coming out on these topics. And first, really dependent on your use case and what you're trying to find. And then having a system in place that can track the different parts of your LLM application system and adding like evaluation. So maybe you have like a different evaluation templates that you can use for given tasks. But in terms of metrics specifically, for folks that are using RAG and using search and retrieval who haven't worked with recommendation system, who haven't worked with search and rank, I highly recommend brushing up on precision, recall, your mean reciprocal rank, your mean average precision, your NDCG, like your typical ranking and recommendation metrics that have been used time and time again by every kind of top company that produces a recommendation system. I say it just because these metrics shouldn't be overlooked. There are new metrics, around, like LLM specific evaluation metrics, like NLP specific evaluation metrics, but I wouldn't skip on the retrieval metrics because you get good retrieval metrics and you do it like at a specific K value. So if you're looking for a normalized discounted cumulative gain, an NDCG at K, that's essentially like if you're looking at Netflix recommendations, you want to be able to see a recommendation that you want in like K equals 3. So your top 3 recommendations, you want one of those to be good. So understanding ranking metrics is going to be very key because a lot of times, if you don't get the relevant documents, you're not going to get very good answers. Like the rest of the system isn't going to do very well. So first, starting with traditional metrics, and like you said, using more than one, not just using one metric, really optimizing for your precision, your ranking, and then that at K, which gives you the relevance. So you want the most relevant materials possible. And then I think what's kind of different about these large language models is you can use you can look at token usage. You can look at your latency. So tracking those aspects as well. For some like large language models tasks, again, I say like, what's your use case? Because if you don't have proprietary data, if you're not optimizing for performance and you want to optimize for speed, doing a lot of these LLM workflows are not going to be the best solution. So that's why, keep track of latency, because even if you have a really solid response, but it's taking 5 seconds to get back to the user each time, you have to look at all those trade-offs together. Oh, Seamus, you're muted.
Yeah, I'm smiling because Sharif and Daniel and Ali, who are on our team, we just had that conversation this morning because we're switching from LangChain to Llama Index and different model architecture, which is not quite there, right? So we're trading latency for speed. So I'm like, better off give them. I hope no one from Cortical is listening. Better off give them not as good an answer and give them quickly than have an answer that's, forget about 5 seconds. Our chain is more like 50 seconds, which is maddening. So no. This is great advice. So I'm glad this is recorded because I'm going to have to go back over this because you rattled off so many different great metrics there, and I think we'll get into in a little bit what tools and features of Phoenix we can figure out for this. So one thing we're always curious about. So again, there's open source models, non-open source models, proprietary models, third-party models, lots of different ways of calling it. And there's some great interaction in our chat there, by the way, people saying what they're using and how they're using it. But one of the things we all struggle with, if we know traditionally in machine learning, if there's something wrong with a model, you go and try and identify the error, it might be drift, something like that, and go back and look at the data, retrain it. So obviously you can't do that with foundation models if it's an error which you're fine-tuning maybe, but anyway, I shouldn't be answering the question myself. So once you identify an error in a large language model, how do you go back and fix those many errors? Is it updating with new or corrected information? What's
Right.
your favorite approach here?
So my favorite approach is knowing the where, because having AI observability, the key thing that we're giving you when you use an AI observability platform is showing where in the model that error is happening. So, and because of the where, it will help you with the how to fix it. And we have like recommended workflows too. We also have our Arize community chat where a lot of folks in our community, where I think around like 5,000 folks in that community ask similar questions based on the experiences they're having. But if you get a bad response, and you're looking and you look at those documents that were, created or retrieved that generated that response, and you're like, these documents, like they do have the answer, but the chunking is all wrong. Like it's cut off too early. So there's like experimenting with different chunking techniques. There's a lot of really cool ones if people want to talk a little bit more about that. But a lot of times people say, like, if the response is good and the latency is good and things are working as expected, everything's good. But as soon as that response starts going downhill, you really have to look at the different parts for that model. If you are retrieving good documents and the language model is picking up on those documents, but there's something weird with the response that you're getting, a lot of times it's because of the large language model or the prompt. So we recommend changing out the prompt and saying, like, only use the information that you've been given in these documents. Like, don't use kind of what you've been trained with to try and predict what the answer is. Like, only use the documents that we made available to you, like through search and retrieval, like through these RAG systems. So just to summarize that point, again, you have a bad response, but you have a good retrieval. It's probably not your documents, it's probably the LLM, but we recommend first trying to work with that prompt to get that LLM to work. If the prompt still doesn't give you a good answer, then maybe changing out the large language model. Fine-tuning is interesting because it used to, like, and when I say it used to be, like 4 months ago, you wouldn't want to touch fine-tuning really with these models if it's a third-party large language model. But now there's very specific models that are kind of designed to be fine-tuned for a specific task. But again, start with prompt engineering before testing out any of this fine-tuning. We recommend prompt engineering and RAG over fine-tuning, just in terms of the benefits that you should see in terms of performance versus the amount of work that you have to put into it.
Yeah, and we'll take a few audience questions in a second because I see one or two that I want to post on there.
Perfect.
But just on the, so very good insights, Amber. We find as well model architecture, it's so important. And even struggling with simple prompt programming or prompt tuning or instruction tuning, lots of different terms for these days. And, and it goes back to your earlier point too about comprehensive evaluation, because that's always been a favorite technique of mine for machine learning, data engineering, software engineering. It's like, sometimes doing comprehensive evaluation at the very start when you're building your models will surface these issues quickly. But moving on to surfacing issues, let's talk a little bit about one of the other problems, which everyone's well aware of, which is the hallucinations of these various models performing. I'm a little reluctant to use that term now because I got educated a couple of weeks ago on it's calling it hallucinations is something that came from maybe large vision models, like hallucinations is basically acid, something like that, and it's not quite correct in text. And anyway, so yeah, let's talk about fixing hallucinations in large language models. If you can address that, and then we'll take an audience question.
Yeah, and it's interesting, the term hallucinations, because mostly these models are just trying to do the best with what they're given, and they're only trying to predict the next most likely steps or most likely turn of phrase. So Seamus, like if I asked you like what was my exact title of my ODSC West talk, you would probably get some of the words, and you could get a majority of the words, and maybe they're not in the right order.
LLMs, LLMs.
Like evaluations, LLMs. But because of the amount of information that has been supplied to you for ODSC West, the amount of talks you went to, the amount of talks you've seen, you're able to give a good idea of like what that talk would be, but you might hallucinate exactly what that talk is. And it's the same with these large language models. And that's why we really tried to prioritize relevance, because it's the lost in the middle problem of when you're giving so much information to these large language models to shift through, and it's constantly seeing like similar phrases. It may not get the exact right answer to a question, but it's a lot of times it's reasonable to see how they got that way once you look at the documents that you're supplying them. So really trying to give them less information, but more relevant information, so it's easier for them to shift through that work. So like if your model's hallucinating a lot and it's kind of coming up with answers that are in the right area but not exact enough, you really have to look at the retrieved documents that you're working with. Because if it's it's hallucinating by phrasing things a little too colloquially, or it's answering all these, it's a medical chatbot and it's answering all these things like, pretty rude, or it's being like overly friendly. For that, you can use some prompt engineering. But if the actual content isn't relevant enough, then you have to go back and check the documents that you're supplying it. But yeah, if your chatbot like, is speaking with like an Irish type accent, like it's typing it out as it would speak, or it's using a lot of like kind of strange vocabulary words, that's more likely to be fixed with prompt engineering.
Yeah, funny story. A couple of years ago, I set my Alexa to speak with an Irish accent. So when I asked it for the weather, it would give me with a Dublin accent, and it drove my kids absolutely crazy. They still don't like that, and I've locked down the settings. So trying to give them a little bit of an Irish accent. Yeah, and it's another observation, just thinking of what you're saying here. There's overfitting, generalization failures, there's errors and biases. And I have a new area, which I don't hear any speakers or anyone talk about, but it's, having spent a couple of decades in software engineering and data and all that kind of stuff, stupid user errors are still a thing. And I have what I call lazy prompts, like, because these are creative models, and even if the temperature turned all the way down, if you give it an open-ended or vague model, because I even see that too myself, I'll give it a, I'm in a hurry, I'll ask it a sentence, I'm not doing very elaborate stuff like I used to, and it will, I'm asking an open-ended vague question, it's going to, try and interpret it, because these models are kind of built to please almost too much. So let's take a speaker question here. Sorry, it just scroll the
Yeah,
way
no
through.
problem. Why you look at that? I would say we've seen LLM assisted evaluations come into play there, where you can give it a simple prompt, and then an LLM designed to create that prompt
Ah,
template will then expand it, make it more exactly what you're looking for, and then feed that into a secondary LLM. So, yeah.
yeah, so that's a great example of, we used to try and architect out stupid user errors, and that's a good example of that, using LLM that. But LLMs, layered in LLMs. So Preetam asks a question: how easy or difficult is it to monitor data privacy and security challenges in LLM apps? Any framework you would like to talk about?
Great question. So when I hear data privacy and security challenges, it depends if that's being asked by like a security engineer or someone on the security side versus like a machine learning engineer, because the security needs and data challenges are different from like a pure like security perspective. It's probably a little different, but I can speak in terms of kind of the some of the monitoring around the proprietary data that you're using. For that, there's a lot of different tools around the like AI governance space and AI observability. For tools like Arize and our open source Phoenix, we monitor the entire LLM application framework. And so Seamus, you mentioned LangChain, Llama Index, both of those have a callback system. So with Arize, you can use either one of those callback systems. Arize is doing a lot of work. We built like an open inference platform. So if you're familiar with open telemetry, it's an open source observability framework. And really, you want to be able to control your data. You're not going to be able to control a third-party LLM training set, but you can control the data that you supply that LLM, and then you should be able to keep all the data that's being generated from that large language model. So that kind of deals with how you store and keep your data. And so just being careful about certain like third-party applications, but using these like open source tools where you can store all your data, store your embeddings within like the environments that your teams are using, and not giving too much access to that proprietary part of your data. So I'd recommend, checking out open source tools like Phoenix to monitor and keep safe the data that's within those LLM application frameworks. If it's outside of those LLM application frameworks and it's kind of outside the realm of LLMs, then there would be different tools to look into for like a larger security perspective.
Yeah, let's talk about Phoenix, because I see a question or two related to observability and evaluation. So tools like Phoenix are very important in this ecosystem because it's still very early on. There's not too many interpretability tools for large language models, so it's still early. So yeah, let's dive a bit into Phoenix and tell us more about that open source project, which I think we already shared a link on, but we can reshare a link about the
Yes.
GitHub link to Phoenix.
Perfect. Yeah, so when you mentioned using Llama Index, LangChain, using these tools, like those are great tools to use. So Phoenix for the traces and spans portion is similar to Langsmith, but it is our open source framework, and you're not locked into using LangChain if you're using Phoenix. So like we have examples with LangChain, we have examples with Llama Index. You can have your own application framework. We offer a lot of the flexibility there because of how you want to store your data. Like you don't have to give your data to certain platforms if you want. You can keep using your data with just open source tooling. So that flexibility option is there, but we do offer the full traces and spans. So every time you interact with an LLM, every time a user invokes an LLM, essentially you might have an agent acting with that LLM. You might have various tools that are being leveraged with that large language model. You might have embeddings. You might have your indexing step. You can have, let me see, some other popular ones, like any like search and retrieval method, like each step there. Essentially, you're recording each one of your steps. you're recording the token count for each one of those steps, and then you can attach performance metrics to each one as well. So you can there's a good new word. You can attach any performance metrics for that large language model, like hallucination scores. You can attach that for that final response, and then you can attach evaluation metrics for each stage. So you can look at your retrieval metrics, you can attach precision, you can attach ranking metrics, and you can also like kind of add flags, for example, around, oh, this is taking really long. This has a really high latency. This has a very high token count, and just be aware of those certain aspects. And then kind of the observability part. So you have kind of the LLM evaluation, and then you have the observability part where you can go in and you can look at the documents, you can look at the query being asked, you can look at the LLM response. And so you just want to be able to keep track of each one of those steps, because for you, when you're asked to, like just how we're doing now, when you ask me a query and I give you a response, it's easy for me to kind of filter out that response, like as I'm thinking about it. But these LLMs, they don't know exactly what you want from that. They're not that intelligent when it comes to understanding underlining context of questions. So you just have to give them like the best leg up as possible. So that's why we recommend all that AI observability, looking at each part of that platform, and then the evaluations that go with each step of running an LLM application framework. Might have been long-winded, that response, but I would have an LLM go back and probably like chunk out a bit of that. But it is a complicated process. So if there's any follow-up questions to that, let me know.
No, I was just looking through the Phoenix GitHub project and looking at your documentation and Arize that, and I think there's so much there, because it is a very wide-ranging tool. And I do want to continue on our discussion of Phoenix, but there's a bunch of questions here that I want to get to, and I apologize if I'm not getting these to these in orders, but
that's all right. And I will mention, I did provide a link for the next event. We have our ragtime event where it will be me and the like our head of Phoenix development. We'll be there talking about search and retrieval use cases with Phoenix. It's very visual. So if some of the stuff isn't making as much sense, it will make a lot more sense when you see it visually tracked. So I recommend signing up for that event and checking it out, because we'll run through the code examples and the UI functionality.
Yeah, the visualization of embeddings is pretty cool. We played around a little with that. So Sharif has a question. How do we make large language models more deterministic? Meaning, how to stop it giving different answers to the same question? Setting the temperature to 0 doesn't seem to do enough. So I think we're going back to the hallucination conversation a little bit, which is fine.
Yes. A lot of researchers are spending time trying to figure this out. I would say if you want it to stop giving different answers to the same question, you might need to essentially cache that question and answer. So anytime this question or a variation of this question is asked, give this answer. And you can have that in a prompt template. That could be an interesting use case for fine-tuning. Fine-tuning is mostly useful if you have very specific examples that you want to explicitly give to your large language model. Otherwise, I would first try prompt engineering. Like anytime, like PS large language model, anytime a question with these topics are asked, give this answer. Don't deviate, give this answer. If you find that it's a little bit annoying that it's changing things up too much, I think that's the only way to really do it. Otherwise, you don't need to use a large language model. Like you can use a different type of model depending on the questions that are being asked. But yeah, caching, prompt engineering, potentially fine-tuning, or using kind of a less sophisticated model. Like these models are meant to be stochastic, and because if you ask me the exact same question, Seamus, 3 different times, I'm probably going to give you 3 different answers.
Yeah, and by the way, we just recorded a podcast, which I haven't released yet, from a open source project called Outlines. It's github.com outlines or something like that. Maybe we can find that link and share with you. So that's for guided generation. We've come across this problem as well. So there's some good open source tools out that. So that's called guided generations, and the project in GitHub is Outlines. And next question from Adeline, if I pronounce that name correctly. How do you improve the multiple capabilities of the model without catastrophic forgetting? I don't think I've encountered catastrophic forgetting, but perhaps you have.
Can you display that question, Seamus? Is it? Oh, perfect. Yep. Okay. Catastrophic forgetting, that's a fun term. Okay, so if you don't want a model, and again, I'm a lot of times talking about how teams are currently leveraging these large language models, which is a RAG system where they are providing additional context, which is their their own proprietary data to a large language model that they didn't train themselves, but they're leveraging. So if you don't want a model to forget information, or a common use case that we're seeing are like the conversations between a customer and a chatbot, you don't want that chatbot to forget the first part of that conversation that it had. And you don't want it to have to keep prompting the user for information that the user already gave. And so for that, I think essentially like attaching metadata can be helpful. Like we use tags in Arize, so attaching like metadata, like attaching different parts like of the conversation. If it's information that's relevant in your documents or in your like internal kind of index that you're using, what you're going to want to do is just keep that information updated and make sure that kind of relevant metrics are in place for that large language model. Oftentimes, if your language model, they don't really forget, but they sometimes lose access to data. So it's not so much that, oh, this model like forgot about it, because you can see everything that it's being supplied if you kind of dig into the observability enough. So making sure that continued access and refreshed access for that model to relevant information. And if you're working with conversations, making sure like those tags or that metadata is attached to certain users or to certain profiles so that information is remembered.
No, that's great advice. And I do recall from the team discussing this with me, using various APIs like the OpenAI API, you can actually work in it without the memorization, so it won't remember the chat history. That's a great option for testing at the start. But when you do want to memorize the conversation, one of the early lessons was that context window keeps getting bigger and bigger. And eventually, because if you're asking a follow-up question or follow-up questions like number 5 question of the thread, that context window is getting bigger and bigger, and you're using up that context window. So it can look like to the end user that the whole conversation has been forgotten. I just recall that myself was an early issue we had. Got quite a few questions on vector databases, interestingly enough. Mm-hmm. So yeah, Mohammed has a question. I should be able to show this. Yeah. I would like to know if there is a large model plus vector database to handle the process of multi-dimensional data.
Okay, so this is coming out a lot. I can maybe send the link to Seamus afterwards. I saw a full chart of the comparisons of capabilities for all like major vector database companies. And so like the capabilities that are available. And it was really nice to see all of those kind of linked because the multidimensional, it's a good question. I would say if vector databases don't currently have that metadata attachment or like the ability to add different layers of data in. They're working on it. I don't want to mention any companies because I know some that do, but I also can't say that other ones don't. And we work a lot with those companies. So they're, and I know Seamus
Leave it to me, Amber. Leave it to me.
I was like, I know Seamus has worked with some, and one that I was going to name did a hackathon with them.
Yeah. Leave it to me.
Yeah.
Yeah. So no, that is an interesting question, and I'm not sure myself either. But yeah, one we're very fond of. It's an open source vector database, and that is Weaviate. But there's a lot of movement in the vector database space. There's traditional databases that are adding on vector capabilities. I think we're doing something with Postgres, and depends. Yeah, it's all dependent on the use case. All right, so let's go back to Phoenix again, because again, I think this is a fantastic tool because we're talking about troubleshooting large language models here, evaluation and interpretability. So I think this is trying to remember where we left off. So yeah, so did we talked about how Phoenix can help evaluate, and yeah, we didn't talk about how Phoenix can help evaluate troubleshooting and fine tuning of large language models.
Mm-hmm. Yes, we can dive into that. I did actually find the link for that comparison chart, and I dropped it in our private chat. So Irina can put that one up. But that was so far the best comparison that I've seen. I've also linked my LinkedIn because I see we have a little over 10 minutes left. So I want to make sure folks can reach me on LinkedIn. You can also reach me on the Arize community Slack if you want to continue some of these conversations here. So Seamus, I believe your question was around like using Phoenix to kind of work, troubleshoot, resolve these models. And a lot of the capabilities with Phoenix come from, one, the traces and spans. So the aspect of doing your AI observability. And then the other aspect is going to be the open inference, where you can store your data. You don't have to be kind of submitting your data into different LLM like application systems. You can keep it in the environment you want and use an open source framework that is built for observability. So being able to leverage those capabilities, leverage like flexibility, really helps you be able to experiment with these large language models. And then once these models are kind of at the production level readiness, those can be put into the Arize platform, where you can implement LLM monitoring. And we do have a prompt playground where you can change out the LLM that's responsible for giving those responses. You can play around with the template. You can play around with the LLM parameters like temperature and like some other aspects there, but we make it really easy that you can kind of play around with the prompt engineering, get that response back. And then for fine tuning, we have some additional information there, but we really encourage folks to try prompt engineering and to try RAG before the process of fine tuning. Like these models, unless they're one of like the newer, like fine tune for this use case LLM, it can be very difficult to try and get them in a place that offers better performance than you would get from prompt engineering. And it's a lot faster to do prompt engineering as well.
Very good insight. Just looking at a question here I'm very curious about, because I think a lot of our audience may be familiar with this, but I'm not. Trying to make sense of it. Let me show this. I'm curious if you can explain the reverse curse issues we observe in large language models. So if I ask a question one way, I guess, what's the weather today in Cambridge, Mass? And then if I reverse it, tell me, or you reverse that question. So I think that's what the reverse curse is, right? Is Phoenix good for evaluating problems like that? I guess that's a
curse. Okay, I'm gonna have to look more into that. But
yeah, I wasn't familiar with myself. I think that was when you reverse the order of asking a question, because I think it goes back to my earlier question about we've seen inconsistently, like some of the user will come to us and say, hey, we just asked this question. I'm like, well, are you sure you asked it the exact same way? You might have reversed the order of the question. right?
Yes, and what sometimes we do see with like prompt templates, like the order can matter. And also if you ask the LLM to provide an explanation, and so if you run a large language model and you get a response, and that response is what we'll say is non-factual, like factual versus non-factual. It's non-factual. And then you run it again, and then it could say it's factual. And you can run it again and say, provide an explanation. When you say factual, non-factual, it could provide an explanation and evaluation at the same time. And it can really, it's really dependent, because this is also subjective. This is, I would say, when things like this happen, of it can flip-flop essentially on responses. It's also difficult sometimes for human labelers to answer it as well. Like, you know, like, tell me the best ways to troubleshoot a model in performance. To troubleshoot a model's performance, like, I can give you an answer, another company can give you an answer, but if it's not just like a, you know, a factual, like if it's not just like a date or a name, or is explicitly mentioned, and it's a more subjective topic, then you can get differing results. Because I have seen people actually now use large language models and AI observability to update previous golden data sets, because it's like, oh, these were, you know, annotated by a human, these are 100% accurate. But as times change and more information becomes available, sometimes the data within that also changes. So the subjectiveness and the stochastic nature of these are two factors that we have to, you know, now consider, especially if there isn't a perfect answer that's available.
No, I think that's good insight. And we are running out of time here, Amber. So I do have a bunch more questions on Phoenix, but I'd leave it up to our audience to go check out that project and on GitHub, and also Arize. You guys there, Amber, do a fantastic job of documenting this. Some great documentation around it, different things, and it's very, very well thought out. Because I do want to get into some career advice. So I know you give a lot back to the community. You speak at conferences like ODSC. You run workshops all about learning, and that's fantastic. And as we all know, it's an incredibly exciting time to be getting into AI. Do you feel that path to AI has changed, and what advice do you give to both aspiring practitioners and people who are currently working in this field?
I would say, for those who are wondering if they should kind of engage in this field and get involved into it, to just go for it. It's a very exciting time to be in AI. We're seeing such advancements. I know you and me, Seamus, we're learning new things constantly. Every week there's something new to learn. There's a new platform, there's a new use case, there's a new metric for success. And like, just the fact that some of these questions that were being asked, you know, I didn't have the right answer there, because there wasn't a set answer. It's based on just current research, that a lot of this I've seen, you know, this year for some of the research in these topics. And so I feel like it's a kind of similar to like machine learning engineer in like 2016, where people are looking for machine learning engineers and hiring folks with 6 months of experience. And that experience was playing around with these models like on their own time, and kind of building personal projects. Anyone that says they're looking for someone with 3 years of LLM deployment experience, I don't believe the job posting for some of these. Most people are in the same boat.
Wait. So that job posting of a prompt engineer for $600,000 is not real. So I should withdraw my.
We don't know about that. Like we don't know. I haven't talked to anyone that.
Sorry, I didn't mean to interrupt, but I couldn't resist. Go ahead.
No. I haven't talked to anyone that actually holds that role. But it's,
I think that was resume skimming. They were just trying to gather a bunch of resumes.
Yeah, I'd be interested to see, like, if you get an interview with someone who is, making 600K as a prompt engineer, I will definitely tune in to that interview, Seamus, because I mean, it's so interesting, and there's such a variety of topics, of use cases, but it's in its infancy. Like this time last year, we weren't talking about these large language models. We didn't have these leaderboards. Like there were a few people like mentioning it, but it was around kind of February, March last year that it really took off. And so all this information that I know about large language models, productionalizing large language models has come from the last year and just seeing all this research. So if folks are interested in this type of career, there's so many workshops, there's so many open source software to choose from. It's almost like a paradox of choice because there's so much to look at. You don't know where to start. So I would recommend like doing a lot of these free workshops. We have a workshop next week. We have these Arize paper readings coming up. Join a lot of communities like the Arize AI community, get involved, and start working on these projects. That's the best way to understand how all this technology is working, just to dive in and try to experiment and play around with it yourself.
No, I think that's very sage advice. And it's so interesting as well. Like you bring up the concept of how this conversation was this time last year and even earlier in the year. There was I was seeing blogs coming out saying like the role of a data scientist is dead. There's no career in AI or programming anymore, for example. And I think those have proven to be not the fact. And again, from my experience in technology, new products, new breakthroughs lead to new roles. Because again, I'm just looking at the Phoenix website here again and looking at tracing, observability, interpretation. There's a whole new skill set that has to be learned and explained. Yeah. And the other factor is those other machine learning models are not going away either. And all that code base is not going away.
Yeah, so I will say like a majority of models are still the machine learning models, and the role of the data scientist is incredibly important for evaluations of these models, right. For understanding like the inner workings of these systems. Like you might not be training the large language model yourself, but you still have to do the same rigor of evaluations that data scientists have done for each machine learning model that they put in production. So those traditional metrics, and especially like ranking relevance metrics, aren't going away. They're actually just expanding.
Yeah, exactly. And I would encourage people to join your workshop next week, because if you've anything to do with it, it's going to be fantastic. And it's great to dive into this because, again, I would, if I had the time, I would partake myself, but don't want to kid myself. So Amber, you mentioned earlier, LinkedIn is your favorite platform for people to follow you and follow your work and posts.
Yes, I would recommend following me on LinkedIn, and then joining the Arize. If they have like general questions on LLM practice, to join the Arize community Slack. And I think all those links were provided. If there's any links you feel like you're missing, you can reach out to me on LinkedIn.
Yeah, and again, apologies to everyone. That was a very interactive session. There was a bunch of questions we missed, but please reach out to Amber on Slack, LinkedIn, and follow-up questions. Join the workshop. And Amber, thank you so much. Thanks for being an awesome speaker at ODSC, for partaking in so many last-minute events, whether it's our lightning roulette talks, our hackathons, our podcasts. And, very excited to have you at ODSC, because I'm always assured that anyone who comes to your session, your talk, your workshop is going to leave much wiser. So again, thank you so much, Amber, and we'll see you in April.
Thanks, Seamus. Thanks everyone for joining. I hope to see you in Boston.
Okay. Bye for now. Bye. All right, everyone, that's it for us. So do check out our podcast site if you haven't already, so you can listen to this interview and other great interviews. This recording will be on YouTube as well as AI Plus Training. So do check those out, and don't forget to tune in for the next one. And thank you for being such a wonderful audience today, and sharing where you're from, what you're doing, and asking so many great questions. This was truly a very enjoyable interview. Thank you again.